How about the unit vector? Unit vector is usually used, for example, when you have moving vectors. For example, let's say we have a plane. The plane is flying in this direction. Then you can describe this direction, of course, with a vector. But the thing is always, when you have moving vectors, you also want to say something about at which time is the plane where. So you need a moving vector, and the way to do that is you first need the unit vector of this vector, and then you can multiply it with the speed of the plane, and then you have a function based on time, and then you can say where the plane is, right? And so this is one example those unit vectors are used for. So I just made a picture for you to see. And so you have two vectors, a and b, but the problem is they have different lengths. So if I would multiply them with the speed of the plane, of course the result would be wrong. So in order to normalize everything, the procedure is to create those unit vectors, and how to do that I will tell you in the following video. How to calculate a unit vector? Actually very easy. Just imagine you have just some random vectors somewhere. This is a vector, and the thing is, usually the length of the vector is not 1. For example, in this case, let's say length is 5. So how to calculate the unit vector? The principle is we take the length of the vector, which is called the amount. For example, if this is vector v, we say the length is the amount of v. So how to get the unit vector then? So the unit vector, if we have 5, if we know the length is 5 and we want to have a vector with the length 1, then how to do that? So we just say we divide the vector by its actual length, and therefore we receive the unit vector. We say in this case v0. v0 is 1 divided by the amount of the vector times the vector itself. So we divide the vector by its amount to receive the unit vector, right? The vector has a length of 5 and we divide it by its length, then it is the unit vector. Is kind of normalized so that it has a length of 1. So maybe let's calculate an example. So we have example A or something. So we have the vector v, and we should remember the formula. Maybe I write it a little bit bigger. So the formula is, for the unit vector, 1 divided by the amount of the vector times the vector. And this is the formula how to calculate it. If you have maybe problems visualizing it, then you just learn the formula by heart. If you forget the formula, of course it helps if you know, okay, the vector always has some sort of length. All vectors have some sort of length, but in order, for example, to compare them, or if you have some moving vectors or something with some additional unit you want to put to the vector, then you need first to normalize the vector. How to normalize it? You use a unit vector to be able to compare vectors. So we just apply the formula to the example, which is 861. This is our vector. So first of all, we need to calculate this one, the amount. And the amount in this case is, we just add the elements, but not just the elements, but the squared elements, and take the square root. So it's 8 to the power of 2 plus 6 to the power of 2 plus 1 to the power of 2. And we take the square root out of it. This is maybe difficult to calculate. Although we could do it. Okay, we try. 64 plus
36 plus 1 is 90 is 100, 101. Yes. Great. Without calculator. 101. So this is the amount. We just leave it as a square root, and then we can just insert it in the formula. So if V0 is 1 divided by 101 times the vector times V, or we can also write like 1 divided by 101 times 861. And this vector is called the unit vector. Of course, we could also now calculate the square root of 101, but it doesn't really look nice. So to make it look a little bit nicer, we just leave the square root. Also, the problem is always, if you have a square root like 101, okay, it's probably something a little bit bigger than 10, which I will demonstrate in a second. So it's a little bit more than 10, and the problem is always, you see, after this digit is also continuing, but you don't really know. So what is more precise is, it is more precise just to leave the square root like this. If you calculate it like this, you would have to round, maybe like say 10.05 or something. Then it's not very accurate anymore. But it depends on the purpose, depends on the teacher or professor or on the exercise, what is really expected of you. I personally would just leave it as it is. Square root 101, and this is the example. So it's quite easy, and if you can't memorize the formula, just imagine the picture, and the other way around. If you have problems with the picture, just memorize the formula, or best case, you understand both. Thanks for watching.
Practice makes perfect. Further exercises with solutions you can find on my website, which is www.worksheets.com.